determine where the graph of y equals 2 over 2 plus x squared is concave upward or concave downward. Also find the point of inflection. Now, points of inflections are the points where the graph is changing from concave upward to concave downward, or from concave downward to concave upward. So points of inflection is where concavity changes. Now, how do you find the intervals in which the graph is concave up or concave down, and how do we find the point of inflection that separates them? Well, we do it by finding y double prime. But to find y double prime, to find second derivative, you gotta find the first derivative first. So let's start with that. Y is 2 times 2 plus x squared to the negative first power. So y prime is going to be 2 times negative 1 or negative 2 times 2 plus x squared times negative 1 minus 1 or negative 2 times the derivative of 2 plus x squared, which is 2x, and this comes out to be negative 4x over 2 plus x squared squared. Now, to find y double prime, we're going to use the quotient rule. That's going to be 2 plus x squared squared times the derivative of top, which is negative 4, minus the top function, which is negative 4x, times the derivative of the bottom function, which is 2 times 2 plus x squared times 2x, all divided by the bottom function 2 plus x squared squared, which is to the fourth. We're going to start by dividing both sides by 2 plus x squared, which is going to get us, the reason I'm dividing by 2 plus x squared is because we have 2 plus x squared squared here, we have 2 plus x squared, and we have 2 plus x squared to the fourth. So we can divide by 2 plus x squared, getting rid of the excess factors. And that's going to get us 2 plus x squared to the first power now, minus 4, minus 4x, times 2 times, now this thing is gone, times 2x over 2 plus x squared cubed. Simplifying this, you have negative 8 minus 4x squared, oh, this is long, plus 4x times 2 times 2x, that was 16x squared, divided by 2 plus x squared cubed, and that's gonna finally get us to 4 times, let's actually write this out first, 12x squared minus 8 over 2 plus x squared cubed, also known as 4 times 3x squared minus 2 over 2 plus x squared cubed. Okay, that took a while, but we have found y double prime. So now what are we going to do? Well, where the concavity changes, where the graph is going from concave upward or concave downward, is going to be separated by points of inflection, and points of inflection can only occur, the only possible point where points of inflection can occur is where y double prime is equal to 0 or undefined, because when y prime has a relative extrema, that's where the point of inflection is going to be at. And the only way y prime is going to have relative extrema is when y double prime at that point is 0 or undefined, or when y double prime hits the critical point. So let's start by finding the critical point, setting this equal to 0 or undefined. We start by realizing because the bottom 2 plus x squared cubed is always positive, it's never going to be equal to 0, meaning the entire expression of y double prime is never going to be undefined. But can it equal to 0? Well, y double prime is going to equal to 0 when 3x squared minus 2 is equal to 0, and this thing is going to occur when 3x squared is 2, x squared is 2/3, or when x is plus or minus square root of 2/3. So this is a possible point of inflection. It doesn't have to be a point of inflection, but there's a chance that a point of inflection can occur at x equals plus or minus square root of 2/3. So let's check if it actually changes, if the concavity actually changes. Let's make a sign chart for y double prime. Put negative square root of 2/3 to the left, put positive square root of 2/3 to the right, and let's test some points in between square root of 2/3 and in between negative square root of 2/3 and positive square root of 2/3, you have 0. Plugging 0 into y double prime gets us 4 times negative over something positive, and that's going to give us negative. So concavity is negative in between these two possible critical points. And to the right of square root of 2/3, such as 1, plugging it in, you're going to get positive, because 3 times 1 squared minus 2 is positive. And a value to the left of negative square root of 2/3, such as negative 1, plugging it in is going to get you positive again. 3 times negative 1 squared minus 2 is positive 1. So we know the graph is concave up to the left of this point. Graph is concave down in between these 2 points, and graph is concave up afterwards. So we have found where the graph is concave up and where the graph is concave down. Graph is concave up from negative infinity all the way to negative square root of 2/3. And also, this is a union sign, and it means or. Also from positive square root of 2/3 all the way to infinity. And we know the graph is concave downward in between negative square root of 2/3, and positive square root of 2/3. And we know the points of inflections occur when x equals to positive or negative square root of 2/3. If you want to find the y value, I guess you can plug it into the function. Y equals 2 over 2 plus x squared. Y equals 2 over 2 plus x squared. Plugging this in is going to get you 2 over 2 plus 2/3, or 6 over 6 plus 2, also known as, 3/4. So we know points of inflection occur at plus or minus square root of 2/3, 3/4. And that's our answer. And I have a graph of our function 2 over 2 plus x squared from Desmos.com right over here. And as we can see, at negative square root of 2/3 and at positive square root of 2/3, the graph is going from concave up. It's a U-shaped to upside down U-shaped. So concave up to concave down, and it's going back to concave up afterwards.